Hello everyone, I'm Sharanya PS. In this session, I will be discussing about matrix multiplication. How we can multiply two matrices and store the result in one more matrix. As a part of C programming lab experiment number 8, this question will be implemented. That is, the question we need to implement is develop a program to introduce two-dimensional array manipulation and implement matrix multiplication and ensure the rules of multiplication are checked. So, here majorly we are looking to three major aspects. First one, we are discussing about two-dimensional array concepts. We are making use of two-dimensional array since we are working with the matrix. Second one, we are implementing a matrix multiplication. That is, the logic which is used for multiplying two matrices we are trying to implement. Third one, we are following the rules that we need to follow it up when we multiply two matrices. These are the major three aspects we are looking into when we develop a matrix multiplication program. Here, if we are need to mention as a matrices, then it will contain some number of rows and number of columns. It is nothing but it is a representation of a two-dimensional array, which is contains some number of rows and some number of columns. Suppose if we consider two matrices, say for example A and B. A will contain some number of rows and some number of columns. Let me consider now A will contain m number of rows and n number of columns. A is having m and n number of rows and the columns. These rows and columns we normally refer by the order of the matrix. That is, how many number of rows and the number of columns we are specifying is called as the order of the matrix. So, the order of the matrix A is m cross n. Similarly, here we are using one more matrix, say for example B, which is having p number of rows and q number of columns. So, the order of the B matrix is p cross q. And now I want to multiply between A matrix element and B matrix element. So what is the major condition we need to satisfy? That is the first question. That is, if we want to perform the matrix multiplication, then the first rule that need to satisfy is the number of columns of the first matrix must be equal to the number of rows of the second matrix. That is nothing but, in simple terms, n should be equivalent to p. In this case, the columns of the first matrix we are referring by variable n, and the rows of the second matrix we are referring by the variable p. So, to perform the matrix multiplication, n should be equivalent to p. This is the first condition that we need to satisfy. Second one, we will be getting the resultant matrix. The question is, what is the order of the resultant matrix? Which will be the number of rows of the first matrix into the number of columns of the second matrix. That is, the order of the matrix will be m cross q. Suppose if I refer the resultant matrix as C, so C will contain m number of rows and q number of columns. These are the two major takeaway that we have discussed under this topic. Next, if we look into some example, is it possible to perform the matrix multiplication if the orders are like this? Suppose if the A matrix is having the order 3 cross 2, that is 3 rows and 2 columns. Parallelly, the matrix B is having 2 rows and 4 columns. Is it possible to perform the matrix multiplication? What is the condition we need to check? That is, the number of columns of the first matrix should match to the number of rows of the second matrix. In this, the A is having 2 as a number of columns and B is having the number of rows as 2. So, 2 is equivalent to 2. It is possible to perform the matrix multiplication between A and B. And next, the question is, what is the resultant matrix order? That is, first matrix number of rows, that is 3, and the second matrix number of columns, that is 4. So, the resultant matrix will contain 3 cross 4. Next, one more example here. We need to perform the matrix multiplication between B cross A. That is, here B is having 2 cross 4 and A is having 3 cross 2. Is it possible to perform the matrix multiplication? No, because here the order is not matching. That is, number of columns of the first matrix is not matching to the number of rows of the second matrix. If you look into one more example here we have taken A as 3 cross 2 and B as 2 cross 4 and C as 3 cross 3. Now, I want to perform the matrix multiplication between C and B. Is it possible? Yes, definitely. C is having the order 3 cross 3 and B is having 2 cross 4. Is it allowing to do? No, because here it is the order is 3 and here it is having the order as 2. So, which is not possible to perform the matrix multiplication. Now, one more last example, C cross C. That is C multiplied by C. That is, it is having the order as 3 cross 3. So, definitely it is allowing to perform the matrix multiplication. And the resultant matrix order will be once again 3 cross 3. That is, the conclusion remark here, to perform the matrix multiplication, the condition need to satisfy is the number of columns of the first matrix must be equal to the number of rows of the second matrix. First condition. Second one, the order of the resultant matrix will have the same number of rows as the first matrix and the same number of columns as the second matrix. These are the two major aspects we have to remember before we start implementing the matrix multiplication code. Now, the next thing is we will try to analyze the logic or the major thing how we are multiplying between the two matrices. We have come across these concepts in a very long back. Now, just as a recall to those sessions, how we can multiply 2 cross 3 matrix with 3 cross 2 matrix. First thing here we need to check is the order of the first matrix is 2 into 3. That is 2 rows it contains and 3 columns. So, nothing but it contains 3 columns. And second matrix it has 3 rows and 2 columns. So, the condition is whether number of columns of the first matrix is matching to the number of rows of the second matrix. Yes, the condition is satisfied. So, we can move to perform the matrix multiplication. And one more conclusion we have drawn from here is the resultant matrix will have the order of 2 cross 3. That is the result 2 cross 2. So, this is the one more point that we have considered by referring to the order of the given matrix. Now, let us look into the elements of the matrix and start performing the matrix multiplication. Here, it contains 2 rows and 3 columns. This is the matrix A, say for example. And this is the matrix B if we consider. So how we can process with the multiplication of two matrices? That is, rows of the first matrix. All the elements present in the rows of the first row of the first matrix need to be multiplied by each element present in the columns of the second matrix. Plus, we have to keep adding the elements in between. That is 1 into 3 as we mentioned, plus this is the way how we will be processing, and the rows into columns, and 2 into 7 plus 3 into 3. The resultant what we are getting here will be the one element present in the resultant matrix. That is nothing but 1 into 3 plus 2 into 7 plus 3 into 3 will give the result as 26. Next, we have to process with the same row and with the second column. That is 1 cross 5, 2 cross 5 and 3 cross 2. And all the elements need to be added together. That will be the resultant of the second element of the final resultant matrix. Now we are done with the first row and we have obtained the resultant of the matrix first row as well. Next we'll proceed with the next row of the first matrix. That is, for each row we have to multiply, each row of the first matrix need to be multiplied by each column of the second matrix with reference to the element 4 into 3 plus 5 into 7 plus 6 into 3. That will yield you the next element in the resultant matrix. Next, 4 into 5 plus 5 into 5 plus 6 into 2. This will obtain the one more element present in the resultant matrix. So, the final result that we obtain by the matrix multiplication of A and B is C matrix, which is having the order 2 cross 2. This is how we can perform the matrix multiplication. As we draw the conclusion remarks here, suppose if we refer to the first element here as A11, A12, A21, A22 and A31 and 32, that is, it contains the rows and the columns. Then if we want to multiply and find the resultant matrix, that is, the resultant matrix will contain 3 rows and 2 columns, that is 3 cross 2 will be the order of the resultant matrix in this example. How we can perform that? That is, we have to multiply second row and the first column, which will yield the resultant as this particular location. This is how we normally perform the matrix multiplication. If we look into one simple logic, this is, say for example, the resultant matrix. We want to find the result in this particular index, that is C11, that is first rows and first column. Here the row indexes we have referred as it starting from 1. We can refer it normally we will mention from 0. It is not wrong that if we mention from 1 onwards as well. So how we are performing this? That is C11 obtained by A11 into B11, this and this element, plus A12 plus B21 and A13 plus B23 plus A14 plus B14. This is how we are performing the element, and then we are computing the result and storing the result. In the same way, the next way, we have to refer the second row and the second column. This is how we are performing the matrix multiplication. Now, we will try to implement this logic what we have discussed as a C program which will perform the matrix multiplication. Here, we will begin with the two header files. Majorly we are making use of standard input output. Library we have used here since we are using one built-in function which is defined under standard library.h header file, that is exit0, which is allow to terminate the program if some condition is not satisfied, or if some case is matched. If it is going through that particular statement, it is going to be executed. That's why to match to this built-in function exit0, we have used standard library.h header file. If we begin from the main, we have used void main, and we are using some variables to represent the order of the matrix. So as we know, we are performing the multiplication of two matrices. So we want two-dimensional arrays. That is, I have referred the first matrix name as A and second matrix name as a B, or in other terms, it is a different two-dimensional arrays, and the result is we have to store in the one more matrix that we are referred as a C. These are the three different matrices that we refer in this particular program, and these matrices order we have to mention. That is, the first matrix A order is specified by using the variables m and n. Parallelly, the second matrice's order is referred by using p and q. And I, j, k are the variables which are used to process over the different loops present in the matrices. Now, we will proceed with the code by asking the user to enter the order of the matrix. That is, the A's matrix order is mentioned by the variable m and n. Here m refers to the number of rows and n refers to the number of columns. Say for example, if the user has entered 3 and 2, so which indicates 3 is rows and 2 is columns. This is R and rows and columns. Next, similarly, we are asking for the user to enter the order of the matrix B, that is, which are stored in the variable P and Q. And here the major condition need to be checked to perform the matrix multiplication is n should be equivalent to P. Here we are checking whether n is not equivalent to P. If it is not equivalent, in the sense this condition is satisfying, then we mention that the matrix multiplication is not possible, and then we are terminating the program. That's why we have used here exit0. If n is equivalent to P, then this is the else part. Then we will start the matrix multiplication process. First thing, here we have to work with the two-dimensional array. We have to run one for loop, first for loop to read the and to process the rows, and one more for loop to process the columns. And the main thing here is we have to read the elements into the matrix. We have already referred this logic in the previous session when we discussed the two-dimensional element, how we can read the elements of the matrix. Same logic we are processing here. That is, we will use one variable as I, which will beginning with 0 and which will run till the maximum number of rows whichever it is given by the user, minus 1. And here we are working with the columns. This is m is the number of rows, and j, this second for loop we are referring to process with the columns. And then we are reading each element and storing it into the matrix A. And here we have used with that scanf %t &a of ij. Similarly, we are taking the elements of the matrix B. One small change here is we have referred the order of the matrix B is P and Q. That is, P is the number of rows and Q is the number of columns. So, when we write the condition here, it need to take the number of rows at max is, it should be less than the value of the number of rows, and similarly it should be processed till the number of columns whatever it is mentioned by the user, and we will be storing whatever the values entered by the user in B of ij in that particular element. These nested for loops will work one by one element to be stored in the matrix B of ij. And initially we have declared the matrices. Next, the main logic to perform the matrix multiplication. That is, we will start with the one loop I equal to 0, and I will be maximum, it will be processing till m, and as we know, the order of the resultant matrix will be m cross q. And here we will this first loop is to process with the rows, and the second for loop is used to process with the columns, as we followed in the previous sessions. And we will be using one variable, that is C of ij. Here C of ij refers initially in the very beginning, the first location we will set it whatever we are processing as a 0. Otherwise, some garbage value will be referred. That's why in order to overcome that, we will initially set with the value 0. And each time we should keep updating that resultant in the next iteration. That's why we will be using this variable as we referred with the sum in the previous sessions. Then one more for loop that we are using here to display the elements of the resultant matrix. As we discussed previously, the first for loop is used for rows, and second one for column, and third one for displaying purpose. Similarly, here in order to perform the actual calculation, the logic need to be written inside the third for loop. What is the logic we use? Here we are referring one statement, that is C of ij. This is the location of the third matrix, that is the resultant matrix we refer by C. And ij is mentioned with the index rows and the columns of this. That is, with that C of ij initially will be 0 plus the first rows of the first matrix and the first column of the second matrix. Like that, each time it will be processed. Here the main condition we refer, C of ij is equal to C of ij. This is something like a sum that we are calculating each time, plus A of ik, that is we are processing with the first rows and the column what we are referring in that, into B's corresponding columns, B's corresponding elements, corresponding column we are trying to refer. And then we will see with one example how this, the formula what we have mentioned here is going to work. And we will be terminating this inner for loop and next J for loop and the I for loop. Now let us take one example and process this loop what we have written. Say for example, we have used the two matrices A and B with the maximum order of these as 10 cross 10. And we have taken the values for M and N from the user as 2 and 2. Parallelly, P and Q's value is also 2 cross 2. That is, we are multiplying A with the order 2 cross 2 and B matrix with the order 2 cross 2. And here the main first condition it checks is whether n is equivalent to p. Yes, the condition is true. N is equivalent to p. So it continues this multiplication. Otherwise, if the very first if condition we have written, that is n is not equal not equal to p, then we write the statement as matrix multiplication is not possible and the program terminates. Here it comes to the else part and it is going through all the different stages. Here we have m refers to the row size of A and the Q refers to the column size of the B. So the resultant matrix will have the order of m and q. That's why we have written here the row will be maximum, it will be processed till m, and the column will be q. And here we are referring with one more variable as n. That is with the here either we can write n or we can also write q. It does not matter. Here we are taking k is less than n. That is we can either write n or even we can write the p because these both are equal. So we are taking here as it needs to process till the number of rows. Now if we refer with the two matrices with these elements, that is 2 cross 2 matrix A and B are with the element 1, 5, 3, 2 and matrix B with elements 2, 3 and 4. How we can perform the matrix multiplication with this logic? First, I will proceed with the two major iterations. The same process will be repeated for the rest of the elements in the matrix. I will be 0 and j will be 0. We will start with initial C of ij with the value 0. And with the k equivalent to 0, it is coming inside the loop. And it process with the first location with the matrix, final resultant matrix in the location C of 0, 0. First it will be, the value will be 0. A of I value is 0 and k is 0. That is this row, first row's first element will be referred and need to be multiplied with b of 0 and 0. 1 need to be multiplied with 2 and the plus c of 0, 0 that we will mention, that is first row need to be multiplied by first column and then the result what we obtained need to be added together. That's why we are using this, the resultant we are storing it in C of ij. That is the purpose why we are using this C of ij. And we have set with initial value 0 just to overcome that garbage value whatever it will have. And so we computed 2. Next, k will be incremented. That is, we have computed first processed with one element, next k value is getting incremented. Now with the k value 1, it will be processing the next element, that is a of 0 and a of k, that is here it will be referred. So it is referring to the second element present here, a of I into a of k. K value is having as 5. So 5 and cross b of 1. 1 is having 2. We will have 1 and 0. 1's corresponding value will be what it is having here. It is having 4. Please ignore these I values what we have mentioned here, which will not be applicable here. This is just to represent the number of rows and columns, just to proceed it with the I value and j, here it is mentioned. So this complete, previously we have computed 2, it will be added to the next element, that is 5 cross 4 value. So we are getting with the value as 22 and it checks. Now the k value is getting incremented, k is now becomes 2 and checks the condition 2 is less than 2. No, it is coming out of the K loop, and J is getting incremented, which is of a outer loops. And now the one element of C of 0, 0, that is this I value is also 0, J value 0 is also 0. Its corresponding element is computed and it is stored as 22. Next, I will be getting increment, I will stay as it is. J, it is not yet finished with the J has incremented now with the value 1. And the C of 0, 1, it will be set to 0. And next, it will be processing with the K value 0, 1 and 2, similarly as it done in the previous iteration. It is processing the next column, rows and the second column, that is C of 0, 1, that is J, and then A of 0, 0, first element will be referred, and then next B of 0, 1, that is it is referring to 3, and then it is computing the result and it is displaying it as a value 3. This 3 need to be added to the next step, that is we are stored in C of 0, 1 will contain the value 3 with the value K equal to 1, 3 plus A of 0, 1 is having the value 5 into 1, the second element of the column, that will be multiplied and the final result will be 8. That will be stored in the C of 0, 1 location. That is the first row and the second column will be calculated like this. Like this, it is going to process with each element present in the rows of the A matrix will be processed to the each column of the second matrix. And in the next iteration, I will be getting incremented and each row of the first matrix will be processed with the columns of the second matrix. This is how this logic will be processed. And finally, we need to print the matrix A and B to the output screen. One small change with respect to what we have referred to read the elements of the matrix. Previously, we used to refer as a scanf. In order to print, we need to make use of printf statement. And we are not using ampersand symbol. And here we are using printf with the new line just to make sure that the line first row after finishing first row display, the next line is coming in the next line. That's why we are using printf/n. And next we need to print the resultant matrix. What is the order of the resultant matrix? It is nothing but m cross 2. That's why we have to run this I loop till m less than m, and j loop we have to run till less than q. And the resultant is present in the matrix C of ij. So we are inside the printf statement, we are writing C of ij. And here the new line is specified after printing each row by using the /n. And this is how it will be displaying the output. If we look into the flowchart of this corresponding program, first we will begin with the start, and we are reading the values of this m, n and p, q, and checks with the condition whether n is not equal to p. If it is true, then we print as matrix multiplication is not possible and we are terminating the program. If not, in the sense else part, we have written all the rest of the logic. That is, first for loop we have mentioned here, which will be running till I 0 to m to the number of rows. This is for reading the A matrix. If it is true, it will be processed with the next column, and if it is true, then it will be reading A of ij. And if it will be same, this inner for loop will be keep processing. If it is false, then it will increment the first for loop. This is how this inner for loops, whatever we are mentioning, nested for loop will be specified by using this flow chart. And if the first for loop is false, then it will move out of the entire logic. And the same way, the second matrix B is spread. That is for I equal to 0 to P equal to P and Q is the order of the second matrix. If first for loop or the outer for loop is true, it will come inside the inner for loop. And then if inner for loop is also true, it is going to read the statement. After reading that, first it will go and increment the Q value, and then it checks the condition. If it is true, then the next reading process continues like that. Inner for loop will be keep repeating. That will be referred by using this dashed line. And suppose if a similar way, after finishing the column, the I value will be getting incremented. That is done in this manner. If it is false, it will go and increment the I value, and once again the process will be repeated. That's why this false condition is mentioned. All the time, whatever the conditional statement we mention, it will contain two cases. One will be true case and one more will be false. We have to specify in the flowchart. If it is false, it will come out of the for loop. And next one, this is to display, to process the computation of matrix multiplication. That is, here I 0 to m and j is processed 0 to q. And we initially set c of ij is equal to 0. And k will be processed till 0 to n. If all these statements, each condition is true, then it is computing c of ij is equal to c of ij plus a of ik into b of kj, the major logic which is used to perform the matrix multiplication. If it is false, it will be going to check the condition, and this process will be keep repeating. And then suppose if this condition is false, it is coming out and it is going to the first for loop. And if the second for loop is false, it is going to the first for loop. Like that, this process with the each iteration of each for loop what we have specified. And when it is false, it will process with the next set of statement it is written. And here the same logic what we have written here, apart from we are printing c of ij. This is how we can write the flowchart to represent the matrix multiplication. Here first thing is we have to write the conditional statement, since we are using for loops, nested for loops especially, and this nested for loops will have all the time, it will be having true and the false condition. Those true and false need to be connected to the specific location. And if we now, this is how we can implement the matrix multiplication. If we look into this, it looks very complex, but if we start working on implementing, it is not a much complex task. Now let us look into how we can implement this just by writing the code. Here we have started with the main, and we have used A and B and C matrices with the maximum rows as 50, that is order of the I and J values are maximum 50, 50. And here we are using M, N, P, Q, I, J and K to process with the each matrix. And the order of the matrix we have taken as an input from the user, and the order of the matrix B also taken from the user. Now, we are checking the condition whether n is not equal to p. If it is true, it says that matrix multiplication is not possible and we are terminating the program. So I will mention exit 0 here, and parallelly I will be using one more header file #include and it is stored in the header file stdlib.h. And as a else part, we have written all the logic to perform the matrix multiplication. To mention, enter the elements of the matrix A. What is the loop we have to process with? I will be starting with 0. I will be less than m is the order of the matrix, that is the row which is responsible for I plus plus. And inside this we are writing one more for loop to process with the columns. J is equal to 0, J is less than n, and J plus plus. And inside this, the major logic which is required to perform, that is here we are reading the elements to the matrix. So I will be referring it as a scanf percentage %d and percentage %d we need to mention, and then here we are storing the result in A of I and J, that is rows and the columns are specified. And then we are closing this, and here this is where we are terminating this same matrix. Sorry, here I have used one more percentage %d. That is, we have stored it into two-dimensional array. That this set of code we have written to read the elements of the matrix. Similarly, we need to display the matrix A. How we can do? We can just refer the same code with the small change here is, we are instead of scanf we need to write printf. That is, we are printing the elements of the matrix A. Printf percentage %d is not required. We are just printing the result. Sorry, printf percentage %d. Here we are using ampersand. That is, here we are not using the ampersand. This is a one simple statement. Along with this, we have to write one more printf statement which will be allow user to get a proper display of the matrix. That is, with a new line characters after printing each row. In similar manner, we have to take the elements of matrix for the B. That is, here B's number of rows will be P and number of columns will be Q. And here we are referring to the matrix B now. Similar way, we have to display the matrix elements of matrix B. So I will copy the same code and I will paste here. Instead of scanf, here I am trying to write it as a printf statement. And here I am printing B of ij. And after this, I will be writing one printf with /n, which will be allow to provide a cursor to the next row after printing each row elements. And then this is the major logic to perform the matrix multiplication. The order of the resultant matrix is m cross q. So we are running these rows and the columns corresponding loops through m and q. And here the elements of each matrix we are referring to. Here this can be less than n, or it can also be P as well. That is because n and P will be equal if we need to process with matrix multiplication. And this is the major logic. Here we are using C of ij equal to C of ij plus A of ik into B of aj. And finally, we are printing the resultant matrix. That is, the order of the resultant matrix is m cross q. We have specified the, and with the printf statement we are displaying the result back on the screen. These are the this is the closure of the else part and this is the closure of the main function. Now if we execute this program, here we'll see what are the different inputs it is asking for the user to give. Enter the order of the matrix. I will give 2 cross 2. That is m and n value is 2 and 2 now. And the second order of the second matrix is also given as 2 and 2. Now it asks for the user to enter the elements of the matrix 1. I have given, and it display the elements of the matrix A. I need to give the tab as well, that is spacing, then it will be displayed in a much better manner. When we are printing, I have to use /t along with printf %d and a of ij. In that section, I have to give this tab. And it is asking for the user to enter the element of the matrix B. And I have entered the elements, and it is displaying the elements. Now it computed the matrix multiplication, and it is printing the result. The resultant matrix is, it computed each rows of the first matrix is multiplied by each columns of the second matrix, and it is finding the result, and it will be displayed. This is how we can compute the matrix multiplication. One more kind of the code here, it will be, suppose if I mention 2 and order of the matrix, if I mention 2 cross 3 and enter the order of the matrix as 2 and 2. Here the order of the number of columns of the first matrix is not matching to the number of rows of the second matrix. So it need to terminate, that is, it will satisfy that if condition, that is n is not equal to q, yes, then it will display as matrix multiplication is not possible. This is how we can implement a matrix multiplication program. Just as a structure, this program looks much lengthier, but if you look into the logic, all the logics what we use here is almost a repetition kind. Here when we are displaying, here we have to use the /t. Thank you for listening.